Hi guys, this is a simple video on GRE tunneling lab of IPv6 over IPv4. Okay, what we are going to demonstrate here is this is R1 and R2 are the two routers, and they are going to have a IPv6 network behind this R1, and there will be also IPv6 network behind R2, and the network between this R1 R2 is connected via R3, and which is basically IPv4 network. So now we need to tunnel this traffic of IPv6 between R1 and R2 using a GRE tunneling, that is IPv4 tunneling. IPv4 address will be used, and the traffic IPv6 traffic from R1 will be to R2 will be sent via this tunnel. So let's see the configuration part, which is very simple on R1 and R2 and R3. Here in the R1 we are just always we need to enable IPv6 unicast routing because we are going to use IPv6. Similarly, it is applied to R2 also, IPv6 unicast routing. And you have interface loopback 0, that is I am just making a network, IPv6 network behind R1, that is IPv6 address I am assigning as 2001 ABCD colon 1 colon 1 / 64. So there is a IPv6 network behind R1, and also we will have an IPv6 network behind R2. That's what here. This is a loopback 0, and you have IPv6 network behind R2. So we have now there is a IPv6 network behind R1 and R2. So let me just add up something here just to see. Okay, let me just take this, and I can say here this is IPv6 network, right? And also this part is IPv6 network behind R2. So we have two things here, R1 and R2. We have IPv6 network. Here it is 2001 ABCD 1 colon 164. Here 2001 ABCD, this is network 2 and colon 164. So what we will do is we should be able to bring from R1 to the R2 address and R2 to R1. This is what we will demo in this lab, and we will be building a tunnel between R1 and R2, and it will that is basically IPv4. So there will be a tunnel here, and that is you will have a tunnel established between this two. That is GRE tunnel. Okay, this will be a GRE tunnel established between these two. Okay, now how we are going to build this tunnel, that's what we are going to see now. Okay, just take up just create a loopback interface on R1 with this command loopback. You just say R1, this is loopback address is 1.1.1, and then you say subnet mask this is 255.255. Similarly for R2 also you do the same. You create a loopback interface interface 1, and then we need to establish a tunnel between these two interfaces. This is what we will do. And so we have a loopback interface 1.1.1 in R1 and 2.2.2.2 in the R2 router. So how we are going to build the tunnel between R1 and R2? We will be the tunnel will be built, but it will be passing via R3 router. That is, but virtually there is a tunnel built between R1 and R2. It has to be routed via R3. That's how it will be happening. So let's create interface tunnel 1 on R1, and tunnel source is loopback 1. So I am just saying that tunnel source address is 1.1.1, and tunnel destination is, I am going to, the destination address is basically the loopback, other end loopback address 2.22. So there is a tunnel created, and between this and this router, so let me mark it as tunnel. This is the tunnel creation of between the two routers. So you create a tunnel. So, and also we are assigning an IPv6 address on the tunnel. That is what we are doing is, we are putting 2001 ABCD 12 colon 1/64, and the same network 1 to 12 to 2001 ABCD 12 colon 2/64. So we are putting an IPv6 address, and but it will be passing via the tunnel interface, which is built by IPv4. Okay, it's a generic encapsulation tunnel, GRE tunnel. So what we are going to do, other configuration is basically to establish the connectivity between the two routers. That is how we are going to do. So we are creating an interface on this router, that is R1, that is in the gigi interface. We are just using a virtual interface because if you need to have more interfaces, so normally these virtual interfaces are created, and we just put .1q, that is VLAN 13, encapsulation is 13, and IP address as 10.10.13.1. So other end will be on this. So if you look at this, it will be this and this address. Okay, let me highlight that one with another color so that you know. Okay, normally we have to make unshed the physical interface. That's what we have done in this. Physical interface is 1-0, and then we have creating a logical interface, that is basically 0.1.13 on the same physical interface. We are having a logical interface. This is a numbering convention. You can say it's 0.1 or 0.13, because I just want to remember R1 and R3 is 13, and encapsulation .1q13, and IP address is 10.10.13.1 here, and that is between 1 and 3, and the interface IP I just put it, router 1 is 1, and I put the subnet mask, and corresponding interface on R3 is this, that is we are creating again the gigabit interface. Here also we are just creating as a virtual, and correspondingly we are marking as here. So gigabit and .1q and 13.3, so and 255.255.0. This is the, so we should be able to ping between these two routers and via switch, and it is on the VLAN 13. So both interfaces can send up packets and receive packets. So it's a one broadcast domain, I can say that. And then the next one is to, again we have to do it for R3, sorry, R2 we have here the giga interface, and then we are just saying that same, you make the interface up, physical interface, then create a logical interface, that is this 23 is because 2 and 3, that is this is the interface is between 2 and router 3, 23.23, and then encapsulation .1q, and you have IP address 23.2, because the router end is 2, so I put it 2 here. So this and this are, then corresponding interface on the R3 is this. So with this we are just establishing the connectivity between the all these two routers, but it will be via R3. So now R1 is connected to R3, and R2 also connected to R3. So we have the connectivity. But now the important thing is, now R1 should be able to reach R2. That is, when you try to ping 10.2.23.2, we should be able to reach this. But that can happen only when there is a R3 should know how to route the traffic when it receives to for the destination R2. So for that we need to enable routing protocol, which we are doing here, router AGRP, and enabling all the network interfaces. So this will, and also all the three routers. So all these three routers will establish a EIGRP neighborship, and then it exchanges the all the interfaces, and so the routing table will be built on all the three routers. So you can see the configuration of this one, that is router EIGRP. We are just putting this small configuration just to enabling the EIGRP on all the three routers. So now you can see the configuration of all three routers is done, EIGRP. Now with this configuration you should be able to ping the between these two routers, and also you see the loopback address 1.1.1, that will be also on the network interface. So it will be advertised, the route will be advertised this availability of R1 here, and so that R2 will know how to reach R1 loopback interface, and R1 will know how to reach R2 loopback interface. That means once they know how to reach, then they establish a tunnel is established, virtual tunnel is established between R1 and R2. So then after that, what we are just trying to see is, once the tunnel is established, we should be able to ping between the first we can try to ping 2001 and 2001 both IPv6 address on the tunnel. So let me bring up the terminal so that I can show some this on this. Let me drawing, I'll stop it, and just let us open up the terminal here. Okay, R1, and so this is okay, the things are coming up, so I will erase this drawing here so that we don't need it, right? We have just already seen the configuration part. So let me clean up this board. This is draw and then clear all. Okay, I cleaned up. Now let me bring up the terminals of R1. Okay, we have R1. I will reduce it. R1 is there, and then I will bring up R2. The same way I will bring it, reduce the size of it, and I will place it here, R2. Okay, and R2 also is placed. Okay, fine. Then we have R3 also. I will bring up the console of R3 and reduce the screen here, and so now we have R1, R2, R3 on the screen, right? So let me do verifications like say now show IP IP interface brief. So you can see the IP of the interfaces, which is IPv4, and if you want to check ping, we can check the show IP route. So we know the routing of the routing table, and you see here D is basically indicating that EIGRP learned route. So when you want to reach 2.2.2, what is your route? You have to go via this. So and then you can reach. So let me ping 2.2.2. So we are able to reach the other end of the tunnel. And next we look for IPv6 information. Show IPv6 interface brief. So you just look for the IPv6 interface. Okay, this is unassigned and gigabit is okay, and you see that there is a loopback 0, which is basically the IPv6 network behind R1, and you have also tunnel assigned with IPv6 address. This is the end of R1, that is because that's why it's 1 here, and I will ping the other end of the tunnel. Actually we added because the IPv6 route is not advertised through EIGRP, so we added a static route, show IP v6 route. We can just check here. So IPv6 route, if you look here, the routing is if you want to reach the 2001 AED, that is network 2, and we need to go via this it's both are in the same so we can just ping between point to point here. So let me ping this, ping directly connected, right? This one, right? 1 2, that is what it says, right? So local is this one, and via tunnel receive. Okay, let me static address ping this 2. So 2 is the IP interface on the other end of the R2. So you can ping. So the R1 R2 tunnel is up and running. So what we will do is, now we need to ping the network behind the R2. Ping 2001 colon ABCD. I put colon, and we have the network behind it is R2 is 2 colon colon, and the loopback address is 1. So let's ping this one. We are able to ping. So that means we are able to reach the R2 IPv6 network, and it goes via. So I will show you some captures which will be interesting to watch. While pinging, we will take a capture. So I will capture the packet here, so it will capture on both sides. Start a capture. So Wireshark will be starting now, and I will just try to minimize it and show for you how the packets are moving between this. Okay, this is the capture using Wireshark. So I will just try to ping. So Wireshark, it's moving, the packets are moving. You see hello packets are exchanged between this EHRP hello packet 224, and you see here it is this is a protocol, and reply, and all these things are going on here. Okay, so let me, this is a MAC address, and let me look at the now I will try to ping it and see, we can watch this on the screen what is happening actually, the captures. Okay, let me take out the where is the terminal? Yes, I will bring up R1. Okay, R1 is going to ping now. I will send a ping from R1 and see how it works. I am pinging the other end. You should be seeing a captures here. So we will stop the capture and analyze the capture. Stop the capture, and then we will go to the analyze the capture now. See, we see here that is a source address and a generic encapsulation IPv6. So we see there is IPv4. IPv4 is there, and IPv4 I'll just show you this IPv4, and then you have then IPv6. So IPv6 we have this source is this one, and destination. So you are trying to ping the destination to 2.1, and you can see here the packets moves between. This is we need to see the direction of the packet, right? This is a return direction. So if you look for the direction which is from source, so you are pinging from the source 2001 ABCD 12 dot this one to destination 2001, the loopback interface of the other one. So it is literally going via from 1.1 to 2.2, and it is generic IPv6 encapsulation. So packet is generic IPv6 encapsulation packet, flagged protocol type IPv6, okay, x86DD, and version 6, and DHCP, ECN, and all this are there. ICMPv6 and 64, and source address, destination address, and all this. So it's a very simple lab. We have done it, and that way we can route the packet IPv6 packets through IPv4 network and reach the IPv6 network. So it's a tunneling, by tunneling using GRE. Thank you for watching. If any questions, you can leave your comments, and we will get back to you. Thank you.